And let's look at the situation of ordinary pussycats. When I went to Canada, very cold place, the first time, I noticed that all of the cats, they look pretty much the same as the pussycats in Brisbane houses, except Canada's a very cold place and these cats all had thick, fleecy fur. Now, do I think that the difference is that God created the cats in Canada with thick, fleecy fur and he created the cats in Brisbane differently? No, I don't. I believe that they got their differences most likely from adaptation to the cold through natural selection. And many people would say, haven't you just given away the store? No, I haven't, and you'll see why. And natural selection on its own is not the same as evolution. We needn't be afraid of it. In fact, it was a Christian and a creationist called Edward Blythe who first thought of it, who first wrote about it, and he saw it completely within a creation biblical framework, and in fact many people think Darwin might have copied some of those ideas from Blythe. So let's use this hypothetical way of explaining it. Here you have these two cats, a male cat and a female cat, mum and dad, and let's say that there are 3 genes, 3 different places on the chromosome that determine the length of fur, which means that you've got 6. 3 pairs equals 6. Remember, each position is 1 pair, one from mum and one from dad. And let's imagine that there are only 2 forms of that gene that determine the length of hair. And I've drawn the ones that are squiggly. They represent genes that spell out, make lots of fur. The ones that are thin like this, they spell out, make hardly any fur. So because each of these cats has 3 skinny ones and 3 fluffy ones, then that sort of averages out and they have medium length fur. Now if 2 cats like that, I call these the Brisbane cats, you know, where it's nice mild climate most of the year, that sort of thing. If they get married, or however you put that, then in their offspring, there are still 6 positions that must be filled. Now, it's a bit like a roll of the dice. There's no conscious choosing going on, but the offspring can end up with any 3 from dad and any 3 from mum. And so you don't need a degree in mathematics to work out that in the offspring, most of them will end up being like mum and dad. They'll end up having medium fur like that. Now, occasionally, some of them will have 1 more of the furry genes, and so they'll end up with somewhat thick fur. But you notice that when they get an extra thick furred gene, they actually displace, if you like, the possibility of getting as many skinny genes, and so therefore they end up with 1 less of those thin furred genes, and so on you could go. So you imagine you have hundreds of kittens with all of that variety in them, and you dump them off the back of a truck in a freezing cold Ontario winter. Emile Silvestri would rather be there than in a sweaty Sydney summer, but anyway, you will find that at the end of that winter, the ones that are most likely to have survived are the ones that have got more of these furry genes. The next generation, you'll have kittens or cats running around looking more like that. And so the chances of the next generation after that inheriting furry genes is much, much higher. And so it only takes a few winters, because you're getting rid of the cats that can't survive that well because they die from the cold. By the way, that's natural selection, isn't it? Survival of the fittest. It's a fact of life, because the fittest are the ones that survive by definition. It's like saying the sky is blue, blue is the sky. There's no big deal in it. It's just an ordinary fact. But after a few generations, you're very likely to end up with a bunch of cats left over that all look like that. Now, what we've seen is natural selection, survival of the fittest. We've seen adaptation to the environment, haven't we? All these evolutionary words, they've adapted by natural selection. It's a new type of cat, but have we seen any new information added? Let me just stress again the importance of this information thing. You see, in the evolutionary story, once upon a time, there was a world in which there were living things, but there were no lungs. Lungs had not evolved yet, which means there was no information coding for lungs anywhere in the universe, in the biosphere. It had to be written by this evolutionary process. Then later on, there was a time in which there were lungs, but there were no wings yet, no feathers. They hadn't evolved yet. And so the whole evolutionary process, no matter how much information goes up and down, in a net sense, it demands a massive addition of this information. Therefore, it requires, by definition, a process which is in principle capable of doing that. And so if someone shows you a process like this and uses that as an example of evolution, can you see why it's not only irrelevant, it's the opposite of what's required from evolution? Because what's actually happened? Sure, we've seen adaptation, we've seen natural selection, but have we seen any new information created? No. Even more importantly, we have seen information lost. You see, those cats are now specialised for their environment, but they've become specialised through a loss of some of the information, which means, by the way, that they can't evolve any further back in the other direction. Because you see, if you take all of those furry cats and you drop them off in Sydney at a summer super camp in the early stages, they'll all die of heat stroke. Isn't that right? Well, you see the point. You've actually thinned out the information, you've made it less flexible, and can you see how important it is, if God is creating creatures to survive, multiply, fill the earth, to slow down, if you like, the rate of extinction in a decaying, fallen world, it's very important that he gives them a variety of information to begin with so that they can adapt by natural selection in both directions. Some of them will be able to adapt to hot climates, some to cold climates. But the more that adaptation happens, the more specialised things become, the less change you can get from then on. That's why these thick-furred cats can't easily become thin-furred cats, and so on.